Hey Caroline, here's that video on transformations of functions. Let's look at the quadratic parent function as an example. Here's the basic graph of the quadratic parent function. And then if we were to transform that by adding to it, that's going to shift it up. On the other hand, if we subtracted a constant, it would go down. So that's the effect of adding or subtracting c from the function. But what happens if your c is inside the parentheses instead of outside? Here's our quadratic parent function again. And this time what's going to happen is if we add c, it's going to shift to the left. It's going to actually shift c steps to the left. And if we subtract c, it's going to shift to the right. So instead of moving up and down when the c is inside the parentheses, we're moving left and right. Similarly, the coefficient inside is going to stretch or compress the function. So we'll start again with that parent function. If the coefficient in front of the function is greater than 1, it's going to vertically stretch our function. So it's going to get long and skinny. It's like it's reaching for the stars. We call that a vertical stretch. And if the coefficient in front of the function is less than 1 but greater than 0, it's going to vertically compress our function. So imagine a great big weight sort of crushing it. Although really, this needs to go through the origin. There we go. So we've compressed it. It's now shorter and wider. If we allow the coefficient in front of the function to be negative, then our parent function is going to be flipped upside down. So negative f of x for our quadratic parent function is going to be an upside down parabola. If we have the negative inside the parentheses, however, the graph is going to be the same. What this does is reflects the graph about the y-axis. Well, since the y-axis is a line of symmetry for the quadratic parent function, we don't see any change in the graph, even though really the left and right sides have flip-flopped, they've switched, we just can't tell because it's symmetric. Let's look at the square root parent function as a different example of one that isn't symmetric. So this time we're graphing f of x equals the square root of x. And I'm going to use actual numbers this time too so that we can talk about some concrete examples. So the square root parent function looks like that. If I add 2 to that, it's going to shift 2 up. And if I subtract 2 from that, it's going to shift 2 down. If I subtract 2 within the parentheses, it's going to go to the right 2. And if I add 2 within the parentheses, it's going to go to the left 2. So that's what happens if I add 2 within, and that's what's going to happen if I subtract 2 within the parentheses. Here's what a vertical stretch and a vertical compression might look like. We're stretching it by a factor of 2. We're compressing it by a factor of 1/2 vertically. So now let's do some reflections. If we were to reflect the square root of x over the y-axis by doing negative f of x, it's going to flip upside down. And if we wanted to flip it across the y-axis instead of across the x-axis, then it's going to point to the left instead of the right. So in this case, putting the negative sign within the parentheses does make a difference since the square root function is not symmetric about the y-axis. So let's look at an example algebraically and see how I could transform this function, x squared minus 2x plus 3. Well, if we want to move it up 2, all we're going to do is add 2 to it. So now we're going to have x squared minus 2x plus 5. What would we do if we wanted to move it left 3? To move it left 3, we're going to actually add 3 within the parentheses, and we're going to do that every place that we see an x. So this is what it would look like if we were going to take that function and shift it 3 to the left. What if, instead of moving it up or left, we wanted to stretch it vertically by a factor of 3? Well, that would be 3f of x, so we'd be multiplying our entire function by 3. Doing that is going to force our function to become tall and skinny. Check out the website I sent you from Math is Fun for more notes on this and for lots and lots of examples on different ways to transform functions and how to look at them both graphically and algebraically. It's a really great website, and I think it's going to answer any questions that you have left. Thanks for watching my video. It was fun getting to make these. I'll see you tomorrow at church. Bye.